Hi, my name is Zach J, and I'm a tutor here at Chegg.com/tutors. And today we're going to be talking about the fun topic of connective tissues. Okay, so let's get started. So let's first talk about what a connective tissue is not. It is not epithelium, or your skin on the outer layer of like your hand or your face. Epithelium is also located in other places throughout your body. It's not muscle. And it's not nervous tissue, such as your neurons. So what is connective tissue? I like to think of connective tissue as the tissues that hold together or help support all these tissues here, the epithelium, the muscle, and the nervous tissue. And these tissues can come in all kinds of forms. As you can see here, we have 9 different forms. And so what we're going to do in this video is go through each of these forms and compare them with the other ones and give you an idea of the differences between each different type of tissue. A common theme we'll see in a lot of these connective tissues is that most of them will have a cell that ends in the word blast. So in like types 1 through 3 here, the loose and dense irregular and dense regular, we'll see a cell type called a fibroblast. I believe that's also in the elastic and reticular cartilages, or connective tissues. In cartilage, we'll have a chondroblast, and in bone, we'll have what's called an osteoblast. And these cells will secrete substances such as elastin, proteoglycans, different types of extracellular sugars, and that will give structural characteristics to the type of connective tissue we're talking about. And that's really what's going to make the connective tissue what it is, okay? So let's get started. So if we look here at this here, we have a histology slide of normal skin. And over here I have a slide of a tendon, so what connects muscle to bone. So if we look here at the papillary dermis layer, or this pink layer here, we have what's called collagen. And that's what's making this layer pink. It's also what's making this layer pink and this layer pink. So collagen is what the fibroblast, or these little round nuclei here in all 3 pictures, are they're secreting collagen, the fibroblasts are. And so in this picture, the collagen is what's giving these tissue types their characteristics. So what's the difference between these 3 locations? We're here in the papillary dermis. You see how it's kind of loose. It's not real dense, but yet it's still definitely pink, so there's a lot of collagen there. We call this loose connective tissue, or areolar connective tissue. Now it's not dense because it's nowhere near as dense as this here or this here. So here we have very dense splotches of this pink colored collagen, and so this is dense irregular connective tissue because there's no clear orientation to it. So this here is kind of running this way, but that's running vertically, kind of running in that direction. But if we look here, everything's running in these nice parallel bundles. And so this is called dense regular connective tissue. Okay? So basically, to sum that up, the loose connective tissue, or areolar connective tissue, you'll see the pink collagen staining. But it won't be nowhere near as dense as you would see in the dense forms of this type of connective tissue. Between irregular and regular dense connective tissues, the key feature are the fibers organized into parallel rows? If not, and if it's kind of just in whatever orientation it pleases, that is going to be irregular connective tissue, whereas if it's in a nice orderly parallel arrangement, which is really going to give it a lot more strength than it would here, which makes sense because this isn't a tendon. We're talking about dense, irregular connective tissue. The next type of connective tissue I want to talk about is elastic connective tissue. So elastic connective tissue often we'll find in structures that need to extend and then come back together like a rubber band. One such structure is the aorta. And the aorta, I don't know how much you guys know about it, but when blood is pumped from the heart into it, it expands with blood. And then over time, because it has this elastic property, it will slowly contract. That way you get an even blood supply, even when your heart's not actually pumping. So it's really important for nutrient supply throughout the body. Anyway, so the fibroblasts in this case are excreting a lot of what's called elastin, okay? And that is the elastic protein. We got real creative when we decided to name it. And so basically you'll see here we have these white splotches with these like purple lines running between it. And I know this image is kind of blurry looking, but that's actually all these purple lines. And these purple lines, because we've stained it with a special type of stain called elastin stain, are the elastic fibers. And so those elastic fibers are what's allowing the aorta to actually squeeze the blood as it's going. The next type of connective tissue we want to talk about is the reticular connective tissue. So reticular connecting tissue will stain with a silver type dye, so the silver molecules are binding to the reticular fibers. In this case, we often see reticular fibers found in lymphoid organs, such as the liver, spleen, lymph nodes, and bone marrow. And so what it does is kind of support the lymphocytes, which have the your immune response. They phagocytize foreign particles so that your body can stay healthy. But anyway, these reticular fibers are kind of providing this mesh work so that they can have structural support and not just be floating off into your body whenever, and they're only like being active when we need them. The next slide here we have adipose tissue. We have two types. We have white adipose and we have brown adipose. White adipose is characterized by these big white looking spaces with the nucleus being pushed off to the side here. So what happens here is we basically have one big glob of lipids or fats, and that is characteristic of white fat because these are our long-term type storage of fats. And so that's the kind of fat you see in like belly fat or really any fat that is just below the skin, the subcutaneous fat. Brown fat, however, looks very different from white fat in that we have a lot more like little vesicles in each cell, and the nucleus or the nuclei are a lot bigger. So brown fat has all these vesicles because we need to use it for thermoregulation of our vital organs, and that's what refined brown fat is in those locations where we really need to keep our internal organs warm. And so that's why brown fat looks this way and white fat looks this way. So that's the two different types of adipose tissue. Moving on, now we have hyaline, elastic, and fibrocartilage. Hyaline cartilage is often seen in like the growth plates in bones. It has, the blast cell in all three of these types is the chondroblast, cartilage, chondro, and so the cell that's laying down these matrices in all three of these is the chondroblast. So all three of these are kind of for strength and support. So if we talk about where the elastic cartilage is, so the chondroblasts are secreting elastin, in this case just like in the aorta, and we're going to see this elastic cartilage in places like your ear, places where it's not like a vessel, so it needs to like expand, but we want it to be flexible, and so we need this elastic to be flexible. Fibrocartilage, the chondroblasts are excreting more fibrous materials in this case. That's why it's called fibrocartilage. And these fibrous materials are a lot less compressible, and so they work very well in places where we need to prevent compression, such as our spinal cord. So between the in the intervertebral disc, we have they're actually composed of fibrocartilage. Our next slide here is of bone. We have two different types of bone here. We have compact bone here on the left and trabecular bone here on the right. This is also called spongy bone. The difference between the two is the compact bone is much more strong, it has these round looking osteons. That's just what it's called. And basically, if you think like a round tube, and you have really tiny round tubes, they're actually pretty strong, especially if you stack them vertically. And so that's kind of what's going on here, and that provides a lot of structural support. In the case of bone, our blast cell is the osteoblast. Osteo stands for bone, and blast is the cell that secretes the substance that makes it up. In both types, we have the osteoblast being calcified, and that turns into a it turns into an osteoclast once it's calcified. So all these cells trapped inside of this matrix here are osteoclast. Same thing is going on here with the trabecular bone, only instead of having this nice circular strong arrangement, we have more of a loose meshwork type arrangement, and so these are really good for like nutrients absorption and flow into the bone. And a lot of times we'll see these in places such as the head of the bone. So if you think of like my arm bone here I would have lots and lots of trabecular bone, and down here lots and lots of trabecular bone, and all the way around it, on the outer surface, I have that hard bone here, or the compact bone. Okay. And finally, we come to blood. So blood is our last type of connective tissue, and that composes of course, the red blood cells, or the erythrocytes, and the white blood cells, or leukocytes. So red blood cells, these right here are more of the supportive role, mainly. And so the red blood cells are supporting the other tissues by providing oxygen for cellular respiration. And then, of course, the white cells, the monocytes, lymphocytes, neutrophils, those are all really important for the immune response and getting rid of toxic and dangerous foreign particles. Okay? So, once again, my name is Zach J. I'm a tutor here at chegg.com/tutors. If you have any questions about this video or anything related to this topic, please feel free to reach out to me on chegg.com/tutors or any of the other tutors there, and we'd be happy to help. Until next time, have a great rest of your day.